Hello and welcome to another installment. We are talking about indices and surds. We are getting today into multiplying and dividing the surds. Okay, so we talked a little bit about properties in one of our previous videos. We're going to use those properties again today. I'm just going to talk about how you do this pretty well, pretty effectively. So just properties, just to kind of remind you a few bits and pieces. Firstly, if you have a times b under a surd, that's the same as root a by root b. And secondly, we said that root a on b is the same as root a on root b. And this is going to be important when it comes to cancelling. So getting into an example, let's start off with something like this. Let's simplify 3 root 2 by, let's go 4 root 5. Just keep the numbers all distinct. Make sure it's not going to cancel super easily. In general, what the rule is, coefficients first, surd parts second. So coefficients first, multiply the 3 by the 4 to begin with, and 3 by 4 is simply 12. So that is all good in the hood. Then we do our surd part. Our surd part is 2 by 5, which is going to be 10. So root 10. That's my answer done. I'm done. Okay. I can simplify sometimes. This one here will not simplify. I identified that from the get-go already. So what you're really seeing here, that's the process in general. If you remember nothing else, that's a pretty good thing to remember. Breaking down how it actually works. Order doesn't matter when you multiply. So what we can say, that sum we've just done is literally the same as doing 3 by 4. So the 3 and the 4, the constants out the front, by root 2 by root 5. So 3 by 4 to begin with at the front here, that's just 12 like we said. And then this 2 and this 5 here, that's the same as this rule here. So I can combine them under a square root sign. That's going to get me root 10. So that is multiplying in a nutshell. Let's get some more examples though, because that's probably going to require a little bit more thought than that. So taking on something like root 3 multiplied by 2 roots, let's go to root 12. Okay, so again, same as before, numbers out the front first, the coefficients first, so we're going to go 1 by 2, and that's going to get us 2. And then doing the surd part, we've got 3, we've got 12, 3 by 12 is 36. Okay, so in a nice world, we're done. Okay, the 1 by 2 is 2, 3 by 12 is 36. Unfortunately, in surd world, we're always checking to see what we can cancel, and root 36 will cancel. Hopefully you're identifying root 36 is 6 squared. Okay, so I can write this instead as being 2 by root 6 squared. The square root and the square undo each other, so it's 2 by 6. Which is 2 by 6 is 12. Okay, so it does simplify down to 12 today, which is a little bit nice, a little bit interesting, but always checking for that simplifying. The process from the get-go looks nice. Simplify away, please. You can do it with 3 surds as well. So taking, keep the size the same, trying to change the color. Excuse me. If we have 3 surds, so if we have minus root 3 by 2 root 6 by, let's go 3 root 5, for example. Again, coefficients first. It doesn't matter that there's 3 surds here. Don't get freaked out by it. It's minus 1 by 2 by 3. So 1 by 2 by 3 is 6. That's minus 6. And then looking at the surd part, the 3, the 6, the 5, 3 by 6 is 18. 18 by 5, top of my head, I think that's 90. Okay, and again, checking to see where you can simplify. So this is going to be minus 6 root 9 root 10, which is going to be minus 6 by 3. So it's going to be minus 18 root 10. Okay, and that's it there and done. On occasions when you do this, like this example above here, that root 12 could be simplified from the very beginning. So what I did 1 by 2 to get me 2, 3 by 12 to get me 36. Really, I could have simplified this first, and I could have rewritten my question as 1 root 3 multiplied by 2 root 4 root 3, i.e. 1 root 3 multiplied by 4 root 3. Okay, so that would then become 4 root 9. 4 root 9. Root 9 is 3, so 4 by 3, which is 12, which is what we got. So it can make things a little bit easier, but always checking to simplify in the end, because what's going to happen, always checking to simplify at this stage here, because what happens often as you do your multiplication, we make it so square numbers kind of come out. You've got a 3 here, this 6 here is 3 by 2. So you've got 1 3, 2 3s, all of a sudden you've got 3 squared. So just checking at this stage here would be fantastic. That's the simplest case of multiplying. Dividing is not really a significant step from this. So looking at a dividing example, for our dividing example today, we'll begin with something like, let's go 4 root 6 on 2 root, and we'll go 9. Okay, so what we did before, we did coefficients, and then we did the third part. We broke it down into 2 parts, and similarly here we can break this down into 2 parts as well. So basically what you want to do, the quickest and easiest way is do that, and then come along and do that as well. So simplifying this, doing the blue first, it's the same as 2 on 1, and then looking at the green, 6 on 9 is 3 on 2, so root 3, sorry no it's not, it's root 2 on 3, root 2 on root 3, and that's my question done, i.e. this is going to be 2 root 2 on root 3. In a few lessons time, we're not going to accept having a square root on your denominator, so just be aware of that. That will kick in a bit, but for now we're good with that. Constants first, third part second, all good. So we divide the constants out the front here by 2, we divide these here by 3s, and life was pretty good. What's really happening, what you can think of it as being, as a side note, you can think of it as being 4 on 2 multiplied by root 6 on root 9. So that's the same as 4 on 2, which can simplify, by root 6 on 9, which is from the rules. And 6 on 9, you can simplify that, like we saw 2 on 3. But that's going to be your answer for that. Okay, let's get another example, because the dividing can be a little bit interesting. Let's take 6 root 8 on, let's just say, root 2. So looking at this, in a similar fashion to last, take the coefficients first, 6 on 1, so it's 6 on top. Then looking at the third part, 8 on 2 is root 4. Now we've basically cancelled the bottom, so we can put a 1 on the bottom as your denominator. It doesn't need to be there. It doesn't make a difference. So basically you've got then 6 by 2, which is 12, again for your answer for that. Okay, and that one there has got a rational denominator, so that is looking very nice. If you've not got, I'll just do it in one page, just to try and keep your division on one page. If you've not got a third part on the top, that's fine. So if you have something like 3 on 12 root 2. That is going to get you, just cancelling the constants out the front here, is going to be 1 on 4. And the surd part's not affected. So it's 1 on 4 root 2. Of course, like I said, the surd part on the bottom will not be accepted. This part here will not be accepted in a few lessons' time, but for now, it is all good. One other application of this, which we'll talk a bit more about in our next lesson, is just expanding in this sense. So if you're expanding something like 3 root 2 multiplied by 4 root 5 plus 6 root 7, you can expand this the normal way you'd expand, taking what's out the front here, multiplied by this, and then multiplied by that at the back there as well. First terms first, 3 and 4 is 12, 2 and 5 is 10, and then for your second part, 3 root 2, 6 root 7, 3 and 6 is 18, root 2, root 7 is going to be root 14. So just be aware that is coming for you as well. Look to simplify as your final step always. There's no simplifying that can be done. 14 and 10 cannot be broken down any further. So that's multiplying and dividing surds in a nutshell. I would probably suggest pausing the video, going back, doing a few multiplying, watching a little bit, do some dividing questions, and just get yourself really familiar, because this process comes up time and time again. But thanks for watching.